Assalamualaikum. We meet again in this the last part of part 1, the last part of part 1, chapter 3 of the notes. Okay. Okay, sorry. Okay, so now we are, after we have discussed the example of Bessel table. Just now we have discussed the how we can relate the modulation index and the value of the sideband. So now, so you can relate the sideband. This is the value from Bessel table. Okay, when you get the value of modulation index, and this is multiplied by amplitude of carrier. Okay, all multiplied by amplitude of the carrier, EC. Yang lupa pula ni. Okay, so you get the amplitude of sideband. Okay, so this is m equal to 2, so you get here m equal to 2. So this is the amplitude carrier. This is sideband first, second, third, and fourth sideband. Okay. So now we discussing power in FM signal. Power in AM amplitude in the previous chapter 2, amplitude modulation. Since the amplitude of carrier is changed according to the input signal in AM, the total power of AM wave is equal to the sum of carrier power and sidebands. So this is in AM, amplitude modulation, previous chapter. So, but in this chapter for FM, not similar to AM, unlike AM, the amplitudes of FM signal is constant. Yes, the amplitude is constant. Therefore, total power in FM is equal to the power of unmodulated carrier, PC. Okay, so total power of frequency modulated signal equal to total power of unmodulated carrier. But the carrier power in FM is redistributed among the carrier and sidebands. Therefore, the total power PT is equal to P carrier P0 plus P1 first sideband plus P2 second sideband plus blah 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 plus N sideband. Okay, so total power in AM equal to P carrier, okay, P0 equal to modulated carrier power, P0, okay, P1 power in the first set of sideband, kiri kanan, left and maksudnya 1 kali 2 lah. P2 power in the second sideband, and tak ada dot lah, and Pn power in the n set of sideband. Note that PC equal to VC kuasa 2, VC square over 2R. Okay, ini rumus sama dengan AM. Okay, ini ya, PC, unmodulated carrier. VC is the carrier amplitude square over 2R. So R is load resistance, and PC is not equal to P0. PC is not equal to P0. So not equal to. So PC unmodulated carrier power, this one PC. P not modulated carrier power, R is load resistance. Okay, so PC equal to P total FM. This equation. Okay, next. Power in FM signal. Total power in FM is PT equal to P0 plus P1 plus P2 dot 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 plus Pn. Okay. We can also write this in terms of PT equal to VO square over 2R plus V plus 2, sebab kita ada kiri kanan kan. Kita ada pair of sideband. This is the first sideband. So plus 2 V1. V1 ialah amplitude of the first sideband, V1 square plus V2 square plus 2 Vn square. So V1 ni yang you dah kira tadi dalam contoh yang kita buat tadi. V1 ni apa? Nombor yang dapat tu darab dengan nombor sideband tu darab dengan EC kan? EC. Ada. Where VO, V0, V1, Vn are FM modulated carrier amplitudes and sidebands amplitude respectively. So ini ialah V1, V2, V3, Vn. Ini ialah sidebands amplitudes. Sidebands. Ini. V0 is the carrier, modulated carrier amplitude, V0. Yang J0 tadi tu. V0. Okay. Thus, we can use Bessel table and further improve the equation. So, PT equal to EC square J0 square over 2R plus 2 ni. EC square J0 square ni is equal to V0. EC square J1 square ini equal to V1. Ini V1. Blah, 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 blah. Okay, at the end of equation. Okay, so how we calculate the bandwidth? The higher the modulation index, the higher the value of M. The higher the value of M, the greater the number of significant sidebands. Therefore, the wider the bandwidth of the signal. So kita dah tahu semakin besar nombor ni, so significant sideband semakin besar. Semakin N. Okay. From macam mana kita tahu? Kita tahu from Bessel table. So semakin besar nombor M, penilai significant sideband semakin banyak. When the spectrum conservation is necessary, the bandwidth of an FM signal can be restricted by putting an upper limit on the modulation index. For example, in standard FM broadcasting, the maximum permitted frequency deviation is 75 kHz. Okay, delta F equal to 75 kHz. And maximum permitted modulating frequency is 15 kHz. So FM 15 kHz. So by limiting this frequency deviation and the frequency modulating frequency, we can limit the number of modulation index to 5. 75 over 15. So modulation index is 5. Therefore, you can limit the bandwidth. Okay, how we calculate the bandwidth? FM bandwidth calculation method. There are two methods. FM bandwidth, two type of calculation, two method. One is Cousins rule using approximation. Using approximation, Cousins rule, we can determine the bandwidth of FM signal. So using Carson rule, we use this equation, which is 2, then delta F, the frequency deviation, plus Fm, meaning delta F plus Fm multiplied by 2. Okay, delta F plus Fm square bracket 2. So meaning 2 multiplied by delta F plus Fm. So this is one method first. The second method is using calculation from Bessel table. So using calculation, the equation is 2n multiplied by Fm darab 2. So 2n, the number of sidebands, number of n, number of significant sideband plus Fm, modulating index, modulating frequency multiplied by 2. So you get the actual bandwidth using Bessel table. So Bessel table basically, from the modulation index, we can get the value of n. Okay, so from that we can calculate the bandwidth. So basically, for the normal application, the value of the bandwidth of the signal is normally it's close if you are using approximation or actual method. Okay, this is example. First, finding bandwidth using Carson rule. Approximation, the bandwidth necessary to transmit an angle modulated system is twice the sum of peak frequency deviation and the highest modulating signal's frequency. Okay, so this is signal, this is the modulating signal frequency plus the frequency deviation. So plus this sum multiplied by 2, double. Okay, twice the sum of peak frequency deviation and highest modulating signal, twice, darab 2, where delta F is the maximum frequency deviation, Fm is the maximum modulating signal frequency. All this is the maximum value. The second method is by finding the actual bandwidth using calculation, by looking at Bessel table. In Bessel table, the number of significant sideband n depends on the value of motion index m. Okay, so we know that from Bessel table we can get the number of significant sidebands if we have the value of motion index. Minimum bandwidth is determined mathematically using this equation, where n multiplied by Fm double, twice, ataupun 2 multiplied by n multiplied by Fm, 2 n Fm, or 2 n Fm. This is actual value, where n is the number of significant sidebands from Bessel table. Fm is the maximum modulating signal frequency. Fm is the modulating signal. Okay. So bandwidth basically is from the lower to the highest frequency. Okay. The number of sideband depends on m, the modulation index value. Significant sidebands are those that have an amplitude of greater than 1% in the Bessel table. Okay. So for m equal to 0.25, from Bessel table we get there is only one sideband. So the bandwidth is equal to 2 Fm. For m equal to 2, from the Bessel table we get n equal to the significant sideband equal to 4, right? 1, 2, 3, 4. So n equal to 4. Therefore, bandwidth equal to 2n. Okay. And lastly, for m equal to 5, you can check this later. M equal to 5, significant sideband equal to here 1, 2, 3, 4, 5, 6, 7, 8. N equal to 8. 8 significant sidebands. Therefore, the bandwidth equal to 2n FM equal to 16 FM. Okay, example. Example 1. If the highest modulating frequency, the maximum modulating frequency is 3 kHz, maximum deviation is 6 kHz, find the modulation index and bandwidth using Bessel table and Carson rule. Okay, understand? Yeah? So, frequency, modulating frequency maximum equal to 3 kHz. Modulation index, apa ni? Deviation, maximum deviation equal to 6 kHz. So M equal to delta F over Fm equal to 2.0. Okay, 2.0. From Bessel table, we get n equal to 4. Boleh? Mana Bessel table n equal to 4? Okay, let's check Bessel table. This Bessel table. So n equal to 4. Okay, 1, 2, 3, 4. This is 4. 5 is 0. So n equal to 4. Kita bukan ambil nilai ni. We take this 4 sideband. 1, 2, 3, 4. So when modulation index equal to 2, the significant sideband is 4. 1, 2, 3, 4. Okay. We don't take this value, but we take this value. 1, 2, 3, 4. N equal to 4. Okay. Jelas? Okay. So we get n equal to 4. Therefore, from Bessel table, the actual bandwidth is 2n FM. 2n equal to 4. FM is 3 kHz. This is 3 kHz. The total is 24 kHz bandwidth. Bandwidth is using the same unit for bandwidth is also in Hertz. Same unit as the frequency. Okay, using approximation, Carson rule, approximation method, bandwidth is 2 delta F plus Fm multiplied by 2. So 2 kat luar, delta F is 6 plus Fm 3. So 6 plus 3 is 9. 9 multiplied by 2 is 18. So there is a little bit of difference, but still acceptable. Okay, the difference is small, so we can still accept the answer or both answer. Okay, example 2. For FM modulator with frequency deviation of 10 kHz, modulating signal frequency of 10 kHz, carrier amplitude voltage of 50 volt and carrier frequency of 50 kHz, determine the following. Okay, ni soalan yang agak glamour lah untuk test ataupun untuk final. Okay. Make sure you understand this example. Okay, so what is this? FM modulator with frequency deviation. Okay, frequency deviation is delta F. Modulating signal FM. Okay, FM. Yang ni 10 kHz. Modulating signal FM. Also 10 kHz. Voltage, amplitude voltage of 50 volt ni apa? Ni EC kan. Carrier frequency FC 500. So you boleh tengok dia beza antara FM dengan FC. So FM 10 je, 10. FC is 500. This is 50 kali ganda. Okay. So calculate the following: maximum bandwidth using Bessel table, and minimum bandwidth using Bessel table, minimum bandwidth using Castle rule, amplitude of the side frequencies, and plot the output frequency spectrum. Okay, you can try yourself. The answer is here. Okay, you can go through lah answer ni macam mana. Sepatutnya you boleh faham lah. Okay, macam mana kira M dapat M from the modulated index. You can go to the Bessel table and check. So M equal to 1. So you ada 1, 2, 3. 3 significant sideband. This value 0.44, 0.11, 0.02. Okay. So V0, this one, multiply by 50. 50 ni apa? EC tadi kan? 50 ni is EC ni. EC. Tengok latihan awal-awal tadi. V1 itu Bessel table jarak dengan EC. Okay, ni daripada Bessel table ni 0.44. Okay. Okay, so 0.44 darab dengan 50. Ni darab dengan 50, darab dengan 50. Okay, you get this sideband. So you kena lukis lah. Lukis lah. Basically dia ada 3 significant sideband. Bila ni you dapat darab tu. Okay. Untuk nilai frekuensi, kita ada FC equal to 500 kan. So FC plus minus FM, which is FM tadi apa? 3 kan. So kita ada 497 dengan 503 kHz kan. Ini 500 plus minus 3 kHz. Okay, so for FM berapa? Sorry, FM is 10. Sorry, 10. Sorry So kita ada 10 kat sini. So kita ada 490 510. So FC plus minus 2 FM. So you ada 480 520. FC plus minus 3 FM. Dia ada 470 530 kan. Ni. So 470 sama dengan 530 sama dua ni. Yang ni 480 sama dengan 520. 480 sama dengan 520 sama ni. Sama. Yang ni sama dengan 490 sama dengan 510. 22 sama. Ni kan daripada sini. Ni 22 ni sama. And kita ada VO 38.5. Ni dapat daripada mana ni? 0.77 daripada inilah yang carrier. Untuk nilai carrier satu ni kita ada 0.77 darab dengan EC. Darab dengan EC. Ni. Darab dengan EC. V0 equal to 0.77 darab dengan EC. Okay. Understand Determine the unmodulated carrier power assuming RL equal to 50 ohm. Determine total power in angle modulated wave. Okay, ni kira lah. Using this equation, the power for this equation using this equation. PT, V0, ini gantikan dengan 50. Ini gantikan nilai-nilai dia, nanti dia akan dapat. Okay, so we have exercise 1, exercise 2, exercise 3. Do yourself, please do, because we can have a quiz or test using this example. Using this example like this. The number might be different lah. Maybe this is 20, this is might be a 10. Motion index maybe 1, 1.1, 1.5, 2.0, or 2.5 or 3.0. Depends lah. So ini mungkin 50, 25, 20, etc. So you kena buat lah. Okay. FM application are divided into two broad categories. The primary difference between the two types of FM is the number of sidebands and modulated signal. First is narrowband FM and BFM. Motion index less than 0.5 has only a single pair of significant sideband. Bandwidth of narrowband FM can be reduced to bandwidth 2 by FM, often used for short distance communication using vehicle mount radios and hand carry equipment. Usually the audio and data bandwidth is small. The second one is WFM, wideband FM. Modulation index more than 0.5 has more than two significant sideband like this. You know lah kan, if M is bigger, then we'll have more sidebands. Broadcast FM station use wideband FM. Wideband FM system is able to transmit high quality audio as well as other services like stereo channel and possibly other services as well on a single carrier. Okay, so because it is the bandwidth is high, it can send high quality video or audio as well as other services. Last, frequency modulation versus amplitude modulation. So in this slide, we discuss the advantages of FM. Advantages. Of course, FM has also disadvantages. Ini you kena carilah. Apa dia? So, among the advantages of FM, FM typically offers some significant benefits over FM. FM has superior immunity to noise made possible by Clipper limiter circuit in the receiver. In FM, interfering signals on the same frequency are rejected. This is known as capture effect. FM signals have a constant amplitude and there is no need to use linear amplifier to increase power level. This increases transmitter efficiency. So with that, ada lagi disadvantages of FM. FM use considerably more frequency spectrum space. FM use more complex circuitry for modulation and demodulation. In the past, the circuit used for frequency modulation and demodulation involved more complex. With the proliferation of IC, complex circuitry used in FM has all but disappeared. IC are inexpensive and easy to use. FN and PN have become the most widely used modulation method today in electronic and communication. Okay, so now you already understand the advantages and disadvantages of using FM. With that, thank you very much. Okay, that's all. If you have any question, you can write below. So hopefully you can enjoy watching the video and you can understand. If you can't understand, then please repeat watching. Okay, after watching, make sure you fill up the attendance online form. So fill up each time you watch the video. So that's all for this time. Thank you very much. Thank you for watching. Make sure you subscribe my channel for more video to come. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye.